Hello everyone, my name is Harsh. I am studying in Sri Venkateswara College of Engineering, subject analysis and design of algorithm. Topic Kruskal algorithm. First, what is Kruskal algorithm? Kruskal algorithm is a greedy algorithm used to find the minimum spanning tree (MST) of a connected, weighted, undirected graph. What is minimum spanning tree (MST)? The minimum spanning tree (MST) is a subset of edges in a connected weighted graph that connects all vertices with the minimum possible total edges weight, avoiding cycles. Properties of minimum spanning tree. First, unique MSTs and edges weighted. A minimum spanning tree is a unique if all edges weight are distract. This uniqueness is circular for efficient algorithm executions and guarantees a single optimal solutions. Second, cut properties in MSTs. The cut property states that for any cut is a graph that lightest edges crossing the cut must be part of the minimum spanning tree, aiding and the design the analysis of MST algorithms. How Kruskal algorithm works. Sort all edges in increasing order of their weightage. Pick the smallest edges. Check if it forms a cycle with the spanning tree formed far. If it doesn't form a cycle, include it. Repeat until there are V1 edges in the MST. This is the algorithm of Kruskal algorithm implemented with disjoint set data structure. MST Kruskals. First one A. A will ultimately contains the edges of the MST. Second one, for each vertex V in VG. Third one, do make set. Its initialize disjoint set is. Fourth one, sort edges of E by non-decreasing weight W. Fifth one, for each edges UV in E. Sixth one, do if find set U is not equal to find set V. It means check if U and V are in different sets. Seventh one, then A is equal to AU, UV. It includes edges UV in MST, unions UV. U. Merge the sets of U and V. Merge, it will be merged. Return A. A now contains all edges of the minimum spanning trees. Now we are solving the example of Kruskal algorithm. We are going to do in Kruskal algorithm is we are going to keep including the minimum edges as long as no cycles are formed. Once we covered all the edges, we stop. So let's start since we are going to keep including edges. And we know that the subgraph is going to finally contains all the vertices. Let's first draw all the vertices. I have drawn already. Subgraph is going to have other minimum spanning tree is finally going to include all the vertices. Now let's start including the edges. What are the minimum edges? In this set we have a minimum edges one here and another one is here and a minimum edges one is here. So first let me include this. Now the minimum edges is this. So I will include that. Now in this edge, what is the minimum edge? We have a second here and two here. So first I will include this, then I will include this, then I will have a edge of 3 which is the next minimum edges. Now include 3, this 3. Why I cannot include 3? Because when I include 3 I will be I will be forming a cycle between B and D, BD and E. So since it forms a cycle, I cannot include 3. Now I go to 4. I will go to 4. This 4. I have to force here can 4 is 4 also not include. For this 4 also cannot include because that will create a cycle. It will be create a cycle between D between DP between DP and A. We can include this 4. This 4 we can include because the dust forms a cycle. Now I go to 5. 5 will not include because this 5 will not include because this forms a cycle. We have 6 next largest. Yes, we can include 6. Yes, we can include 6. Now we have connected all the vertices in our minimum spanning tree. Now we can stop. So what is the weight of this minimum spanning tree? We have 6 plus 4 plus 6 plus 4 plus 2 plus 2 plus 1 plus 1. We have 16. Weight 16. So this is how you perform Kruskal's algorithm to find the minimum spanning tree. Gives a partial graph. We keep including the next minimum edges as long as that edges not forms a cycle in our spanning tree. Thank you for seeing video.